So from the practice final, this is number 18, and this relates to our braking distance lesson and homework. And remember, we had this formula here. I just want to remind you about some of these things, the meanings of these values here. The D is the braking distance in feet. And we always need to know what are the measurements of the variables involved in the formulas we use. The V was the speed of the vehicle when it started to brake. And that's measured in feet per second. And so sometimes we had to convert from feet per second and miles per hour and vice versa. The little g is gravity taking effect. And gravity we usually measure at 32.2 feet per second. F is friction. And that depends on the road, the weather, and the tires. And then G is the slope of the road grade. And it's usually stated as a decimal. And for this formula, it has to be stated as a decimal. So we might say a road grade is 4% in this formula. For example, 4% would have to be entered as 400ths. Percent means divide by 100. So which of the variables in this formula represents a constant? So which of the variables in the formula represents a constant? So in a situation like this, the distance depends on the speed, and the speed could be anything. So those two are definitely variables. The friction depends on the tires, the weather, so that's variable. And the grade, could be any slope on the road. So the only constant we have here is gravity. On the surface of the Earth, it's pretty steady at 32.2 feet per second. So G is constant on the surface of the Earth there. So that's the gravity.
Why do you say second per second?
Okay, so gravity affects, actually I'm going to show you with my camera here. And let's see, I need a safe chair to jump off of. Okay.
Oh, please don't hurt yourself.
All right, so I'm getting on my chair and I'm going to jump off. I hit the ground. Now, if gravity just affected my position, then I could jump off the building and I would land just as safely. But I think we all know that if you jump from a higher place, you're gonna feel it more. So gravity doesn't change your position, it changes your speed. So now that's, I'm gonna explain why I use per second there. So let's go back to my screen. So this is a side note. So speed is the rate of change of position. So if I'm measuring my position in feet, speed would be the rate of change of the position, so that would be feet per second. Now gravity it changes your speed, not just your position. If it only changed my position and my speed stayed the same, then I could jump off the building just like I could jump off my chair and I'd be fine. But we know that's not the case. So that comes up to what gravity does. Gravity is a force of acceleration. And what acceleration is, it's a rate of change of speed. So like I took my position here and divided by seconds, acceleration is speed per second. Speed in this case would be feet per second. So then I have to get another per second to talk about acceleration. So if we were talking about acceleration of a car, it would be the change in the speed. Speed is miles per hour. So acceleration would be miles per hour per hour. So you get a double division of time when you go from position to speed to acceleration. Often that's abbreviated as feet per second squared, but I always thought the idea of a square second is a weird thing. I can see a square foot, square second's kind of weird. but here this is a change in speed. So there's the change in my speed. Does that kind of help?
Yeah, it really does.
Okay.
I just wrote it down.
Okay. So back to the problem here. A couple of the things we need to check out is to investigate the relationship between the friction coefficient and the braking distance. We want to hold the road grade still, and they're going to say the road grade is 2%. And there was a prep for this lesson that talked about what road grade means. So 0.02 for the road grade is the same thing as 2% for G. And 2%, 0.02, if I read this slang, when I say 0.02, that's slang. The proper way to read that is 2 hundredths, because that's the hundredths position. So I'm going to write what I said, 2 hundredths. And this right here is really a slope. Rise over run. So that means for every 2 feet I rise up, I'll have run 100 feet. So that's what a 2% or a 0.02 road grade means. And so I just need to pick the correct sentence that has all of this idea about where the idea of road grade comes from. And scanning them, it looks like it's probably this one. I see a 2% in there, and I see 2 feet for every 100 feet. So I just want to double check. The grade of a road is 2%, which is a vertical increase, right? My rise of 2 feet for every 100 feet of horizontal increase. Yeah, so that would be the correct interpretation of G equals 0.02. And this here was covered in the prep for this lesson. This is where they talked about where road grade comes from. So then for part C, we're asked to, given a velocity of 72 miles per hour and the G of 0.02 from part 1, we want to rewrite our formula. So let's go to a new page to do that. So I have, let's see, D equals V squared over 2 little g, parentheses, F plus big G. And I need to plug into this some numbers. So they gave me V was 72 miles per hour. I realized right away that's a problem because I need V to be feet per second. So I'm going to have to recalculate V before I plug it in. Little g, the gravity is 32.2. F I don't know, but I do know big G is 0.02. So before I continue, I need to recalculate V there. So let's see. V equals 72 miles per hour. And I'm going to get rid of the miles by dividing by miles, multiplying by feet. And there's 5,280 feet in 1 mile. So that will help me eliminate miles and get my feet, which I want. And then to get rid of hours, since it's in the bottom, I put hours in the top, seconds in the bottom, and there's 60 seconds in a minute, 60 minutes in an hour. 60 times 60 is 3,600 seconds in 1 hour. So then to get rid of an hour, the hours in the bottom, I have to divide by 3,600. So on my calculator, I'm going to take 72, multiply by 5,280, and then divide by 3,600 to get the V I need to use here. And then I need to square it. There we go. So 72 times 5,280 divided by 3,600. So I get 105.6. If I typed it right, I'll double check that in a second. And that should be feet per second, which is what I need to use the formula. And then the formula says to square that. So I need to figure out what V squared is for the formula too. 72 times 5,280 over 3,600. Yeah, that looks good. And then I just need to take that answer and square it. And that gives me 11,151.36. Did I type it right? Yep, I think that looks good. All right, so plugging that all back in and seeing if I can clean it up anymore. So I've already done a little cleaning up by squaring V. So I have 11,151.36 divided by 2 times 32.2. I can clean that up in a moment. Parentheses, F plus 0.02. And then if I look at the options they give me, none of them look like this. I have to do some cleaning. So the first stage in cleaning is to do that multiplication. So then in my denominator here, 2 times 32.2 is 64.4, parentheses, F plus 0.02. And my recollection is none of them look like that either, but I'm going to go back and double check. And I am confident about my work so far. So I have the right numerator. And they're missing the parentheses on this one, and this one has a strange number. So I got to get rid of the parentheses. Notice there's no parentheses here. Okay, back to the notebook. To get rid of the parentheses, I have to distribute. So that means I have to multiply the 64.4 times the F and by the 0.02. So calculator to figure out what that second one is. What is 64.4 times 200ths? Oh, it's 1.288. I remember seeing that number. So cleaning this up one further step, in the denominator, I have 64.4F plus the 64.4 times the 200ths was 1.288. Yep. And we still have that 11,151 and 3600ths in the numerator, and that does match one of my choices. Right there.
Yeah, it's all coming back to me now.
Right there. All right, let's see. Got a time for another one, so that was a fun one.
Thank you.